What exactly is this 10 referring to? Good. Now, the height of something always has to make what type of angle with the base? Got to be a 90-degree angle, a right angle. So the height would be this distance. Now I put a dot there. That dot is located at what point of this square? It's the center. So let's think about this. Let me see, how do I draw this? Let me do it this way. If that's the center, then how long would this length be right here? Four. So this is 4 because this is the center, right? So if the whole length is 8 inches, then halfway would be 4 inches. And now let's take a look at what we have here. We know that this is 10 inches. That's 10 inches. So I have what type of triangle? I have a right triangle. Yeah. Let me bring it out here. This is 10 inches. This is 4 inches. And here's the height. How can I find the height? It's a right triangle. So what can I use to find the height? Good. We can use the Pythagorean theorem. See, Pythagorean theorem always comes back in ways you're never going to expect. A squared plus B squared equals C squared. So H squared plus 4 squared. Go ahead and find the height. And then once you have the height, find the volume. I'll give you guys about 2 or 3 minutes to do that. And you can round your answer to the nearest hundredth. All right, 30 more seconds. I'll start going over the Pythagorean theorem part of it. So we got h squared plus 16 equals 100. Subtract 16, we get 84. And you take the square root of 84. You get a pretty long decimal, 9.16515. Oops, you missed a decimal. Okay, then once you have the height, you plug everything into the formula. And our final answer comes out to what did we get? 195.41. I know somebody got something very similar. Jalen, what did you get? Jalen, I know you got a very similar answer, but with a different decimal. Jalen? Hello?
Oh, you said my name?
I was saying your name.
Oh,
I was
my
asking
bad.
what you got.
Hold on, I gotta find it in chat. Wait a minute. 19.5.63.
0.63. Janelle's got 0.52. We're all getting different numbers. And the reason is the number you get for the height is gonna change your final answer if you round too early. So this is something that is super important when you're talking, especially about like a real world problem or something that you're gonna round in the end. If you get an answer like this, where it's a really long number, a really long decimal, don't round it. Just leave it in your calculator. So like I have this in my calculator, I'm gonna leave it. I'm not gonna touch it because all I need to do is take that number and then multiply it times 64 and then divide it by 3. Wait, I got the wrong answer. Hold on. So the square root of 84, okay, times 64 divided by 3. I get 195.523. I got the same thing that I think Janelle's got. Yeah. And that number, that final answer, that's what you're going to round. So Janelle's got it correct. So anytime that you're working on a problem like this, any type of problem where you get a long decimal at some point in the middle of the problem, don't round that decimal. Keep it in your calculator. Don't touch it. Don't change it. And just keep working with that really long decimal. So you don't want to round until the very final answer. Oh, it should be 5.2, not 5.3. There we go. Any questions on rounding and how that worked out? Okay, what are my units here?
Inches cubed.
Inches cubed, good. And that's it. So with these types of problems, you might get some easy, very simple, okay, what's the volume type of problems, but sometimes you do have to do a little bit of extra work. So it really comes down to making sure that you recognize all those different patterns and different properties of the shapes that we've been talking about. And if you need a refresher on the formulas for the volume of, we did yesterday, volume of a prism, volume of a cylinder, and volume of a pyramid, make sure you watch the video. I think I forgot to upload it yesterday, but I'll upload it today so that you have it. And we'll be doing a review on those on Friday. So today we're going to move on. Today we're going to be doing volume of cones and spheres. So continuing with volume. And we're going to start right away with volume of a cone. So I'm going to give you guys the formula right off the bat. And that's the first thing I want you guys to write down is the formula for the volume of a cone, which is 1/3 BH, or if you substitute, it's going to be 1/3 pi r squared H. And it's important that you have both of those written down.
And so what is the first one? What is the first formula for?
This one?
No, the second one. I mean the first
This
one.
one.
Yeah.
They're both the same. They're just showing you how the B is over here. So let me highlight that.
Oh, okay, okay.
So they substituted, instead of writing B, they wrote pi r squared. These are the two, yeah, these are the two that you definitely want to write down. If you want to write the whole thing, you can do so. But if you're making, like, remember, we had a list going yesterday. This is what I would put into the list, these two. Now, as we finish writing, I have kind of a comparison over here that I want us to think about, because we've been talking about pyramids. Now we're talking about cones. How is a cone similar to a pyramid, just based on its shape? And then comparing the volume formula, how is the formula similar between a cone and a pyramid? You can put ice cream in both. Okay, that's true. Okay, but shape-wise, what's similar, what's different?
Oh, you're asking us to like actually answer right now?
Yeah, we're talking about it. Okay, one is a circle. So be more specific. Which one is a circle and what part of it is a circle? The base. Good. Nice, good. They both have an apex. Good. So the base over here is a circle. What's the base of a pyramid? Square. Cool. And now let's talk about the volume formula. So we talked about the volume of a pyramid over here. And how is that similar to the volume of a cone? So volume of a pyramid over here. Volume of a cone over here. Yeah, so they both kind of start off the same, but when you get the actual formula, so like this one over here, when you fill it in for B, what's different? Yeah, so since the base of a pyramid is a square, you would use the formula for the area of a square. But since the base of a cone is a circle, you use the area of a circle formula. Okay, so that's kind of the nice comparison and similarity. So when you're memorizing these formulas, you can notice the similarities, and that's going to help you to memorize them. So I'm just gonna do a quick comparison. Oops. Okay, I don't know why it's not writing. What's going on? It doesn't want to write. It just wants to move. Sorry, guys, it's glitching. I don't know why. I don't know why it's glitching. I don't know why during this class I always end up with all the technology issues. See, it doesn't want to write. Okay, I don't know what's going on, y'all. I keep trying to write. I'm literally just trying to write 1/3. Y'all see this, right? It's not just me. Okay, I don't know what's going on. Maybe if I make it bigger. Nope. It's going crazy. Okay, I was trying to write the volume, the volume formula for the cone. So this one's the pyramid, and then this one's the cone. And they come from the same general formula, but when you actually change the value of b, that's what changes. So that's what I was trying to do, but you can do it on your own piece of paper since you have the formula in front of you. Oh, oh, nice. Okay, there we go. All right, so any questions on that? Any questions on kind of the similarities and the differences? Cool. Okay, now I wanted to show you a video that is actually a really interesting way to show how, like, where this formula actually comes from, because it kind of seems a little bit random. Like, why is there a 1/3? Where does that 1/3 actually come from? So I want to go ahead, actually, instead of you guys watching it individually, I'm gonna share a new screen and we can watch it together. Give me a moment while that loads. Okay. I don't think it has sound, but okay, here we go. All right. So I'm going to play it one more time. And now this time, I want you guys to think of I had two questions on the screen before. The questions were, oops, what do you notice and what do you wonder? So let me go back to it. There we go. So as you watch it, just think about, what do you notice? What do you wonder? And you can type it in the chat. All right. So what did you guys notice about this? What do you wonder? I'm looking at the chat now. Okay. The cone has less volume than the cylinder, so it takes longer to fill it up. Good. What else do we notice? If you did it the opposite way, the cylinder would fill up the cone in one, like it would probably overflow, right? The volume of 3 or 4 cones is equal to 1 cylinder. How many was it? 3 or 4? 3, yes. Good. So 3 cones fill up 1 cylinder. And what do you notice? Let me get a good shot of these two next to each other. Hold on. I think there was a pretty good one at the end. Okay. What do you notice about the cone and then the cylinder when they're right up next to each other? Same size. So when you say size, what do you mean? Height. Good. They have the same height as each other. And you can't really tell in this video, but they also have the same exact, see how they both have a circle as the base? That circle has the same radius as well. So you
Miss,
can,
I have a question.
yeah, go
Sorry.
ahead.
So if you were to put like the cone on top, it would serve like a top.
Yeah, perfectly lined up with the circle on top. So basically this circle is congruent to that circle and they have the same height. So that's important as well. And I'm going to play it one last time so you guys can really soak it all in. So they have the same height, same circle radius. That was 1, 2, and 3. Yeah, it's very satisfying. Cool. Now the square that he used, or the cube that he used to fill up the cone, that doesn't really matter too much. I think he just needed to use something in general. Yeah. Okay, so back to our slides. 1 second. Okay, here we go. Back to this, if it loads. There it goes. I added a page because I kind of want to talk about what we just saw. So we noticed that he had 3 cones, right? So I'm just going to sketch it out a little bit. Here's 1, 2, 3 cones equal 1 cylinder. And that cylinder has the same height, same radius of the circle. Okay. Well, let's talk about what is the volume formula for a cylinder. From yesterday's class, what is the formula for a cylinder? Pi r squared times height. Now, this also, we can call it B times H, but we know that B represents the area of the base. And since the base is a circle, that's going to be pi r squared H. Well, if it takes 3 cones to fill up 1 cylinder, each of these cones is what fraction of the cylinder? Exactly. So each cone is 1/3 of the cylinder. So that's where we get the formula from. The volume of a cone is 1/3 base times height, which is 1/3 pi r squared h. So it's kind of cool to see it that way, because when you really are able to visualize it, the formula makes a lot more sense. So does anyone have any questions on that? So for me, I think formulas are awesome if you can memorize them, but they're even better if you can understand where they come from. So understanding where that 1/3 actually comes from can help you to memorize it, actually. All right, so now let's just do a couple problems. Shouldn't be too bad, starting with a couple of easier ones. We're just going to find the volume. So in this case, we're going to use that formula. And fill things in. So my radius, 1.9. The height is 4.2. And then we're going to do it in terms of pi. So go ahead and calculate, see what you get. And once you do number 2, you can go ahead and do number 3. All right, take about 1 more minute. And we're rounding to the nearest tenth in this case.
Miss, did you say you wanted us to do it in terms of pi or like?
Yes, yeah, in terms of pi, and then also to the nearest tenth. Thirty more seconds. All right, so for the first one, after you've plugged it all into your calculator, you should get 5.054 pi. But when I round that to the nearest tenth, what do I get? Not quite, Perla, because what is the 0? Yeah, the 0 rounds up. 0 rounds up, so we get 5.1 pi millimeters cubed. All right, now this one has a slight challenge. Actually, it's a little more challenging. Let's talk about number 3. What do we know and what do we don't know?
We know the diameter.
Mhm.
We know that little side, I guess.
So this is called the slant height.
The slant side. Okay. We do
But-
not know. Well, we can figure it out, but we do not know the radius.
Okay, so how would we get the radius?
Just divide 5.9 by 2.
Good. So what would be my radius?
2.95.
2.95. And what else do we need to find out?
The height.
The actual height. Now we know how to do that, don't we? Because what type of angle does that make? We got a 90-degree angle. We know this length is 2.95. We know this slant height is 6.3. So we're going to go ahead and do the same thing as we did in our bell ringer. Let me move this over for now because we can't use it yet. Pythagorean theorem. H squared plus 2.95 squared plus 6.3 squared, or sorry, equals 6.3 squared. Oops. Now, as you go through it, remember what we said in the bell ringer, try your best not to round it until the very end. And if you do need to round it, because sometimes you have to clear your calculator and then plug it in again into your calculator, plug it in, write it down in your notebook with as many decimals as possible, and then plug it into your calculator. Does that make sense? So don't round it too close until the very end. Go ahead and let's see what we get. All right, take about 30 more seconds, at least try and get the height in the next 30 seconds. And if you finish with the height, you can go ahead and find the volume. All right, let me start going over the height. So again, don't round until the very end. So I'm gonna write it out with all the decimals. So 2.95 squared, I get 8.7025. .3 squared, I get 39.69. Okay, 39.69 minus 8.7025. I get 30.9875. And then when I take the square root of that, I get a really, really long decimal, I'm gonna just leave it on my screen. I'm not gonna touch it. Okay. So that number, which I'm not touching on my calculator, I'm leaving it really, really long. That goes into my volume formula. All right, so I'm now gonna go ahead and use my volume formula. And I'm multiplying that decimal times 2.95 squared. And then dividing it by 3. And when you do all that, you should get 16.1 pi. 16.1. Perla, you got 16.4. That might be because you rounded something else too soon. So if you don't round at all, if you don't round this number at all, you should get 16.1. And that's feet cubed. You did not round at all. So try doing it again. You should get 16.1. The whole decimal is 16.14789, something like that. Any questions on this one? So this one was definitely more challenging, right? Sometimes easy peasy, you just plug everything in, but sometimes there's things you have to find first and then you can plug everything in. Okay, so no questions on this problem? No? Tyrone says no, but how about everyone else? No, we're good? Okay. Okay, what happens if you've got a little bit of a tilted cone? What did we learn about yesterday? Good, what is that? Who's that guy? Cavalieri's principle. Cavalieri's principle. Okay, again, something to remember. That's his name. Cavalieri's principle tells us that as long as you have the same height and the same base area, the volume is going to be the same. So we can use the same exact formula. So we're only going to do one of these. There's no need to do both of them because these are very simple. Plug it in. Oh, actually, no. This is a little bit challenging. Or is it? Oh, no, okay. This is the diameter. I believe this is pointing at the diameter. So we're good. We're good. So the diameter would be, yeah, I thought it was pointing at something else. The diameter is 24, so the radius would be would be 12. Good. What do we get? Go ahead, plug it all in. Who can get it the fastest? Good, 1440 pi. Inches cubed. So the most important thing is it doesn't matter if you have what's called a right cone, or if you have an oblique cone. Either way, the formula is still the same. You just have to make sure that the height makes a 90-degree angle with the base. Any questions?
Miss, it's 1,440, not
Ooh,
100.
You're right. There's my 0. What's your question, Jalen? Perla's not cheating. You need a little more faith in your fellow student, fellow
Are
classmate.
you always lying? I always lying.
All right, last one, y'all. Last one. Who can read for this? Let's have a volunteer. Ha, we're not done. You wish. Okay, go ahead.
An ice cream waffle cone can be modeled by a right circular cone with a base diameter of 6.6 meters and a volume of 54.45 pi centimeters cubed. What is the number of centimeters in the height h of the waffle cone?
All right, so we know the diameter, we know the volume, but we don't know the height. So I want you guys to try this on your own and put your answer in the poll when you're done. I'll give you 4 minutes to work on it. That is so mean, Jalen. I'm gonna screenshot that and show your mother. All right, 1 minute down, keep working. All right, 2 minutes down. Well, 2.5 minutes down. So a little over 1 minute to go. Thirty seconds remaining. Please put your answer into the poll when you're done. Five,
Wait, miss.
four,
Give me 2 more seconds. I messed up something on the calculator and it divided 3 times and it was only supposed to be 1.
uh, 15 seconds.
Why you always lying? Why you always lying? Oh my God. Stop
5,
lying.
4, 3, 2, and 1. Get your answer in. All right.
Pearl loves lying.
You put it in. Good. All right. So there's our results. We were between B and C, but most of you chose C, and that is the correct answer. So let's take a look. Formula is, oops. Oh, why won't it right now? Hold on. Technology these days. Did it die? What's going on? Let me see if, but it didn't tell me that the Apple Pencil was dying, did it? Usually it comes up.
It does
It
that
did not.
sometimes.
It did not. Okay. Sometimes you just have to plug it in to like wake it back up. Let's see if that worked. There we go. All right. So volume equals 1/3 pi r squared h. We know the volume. We know the radius. What's the radius? .3. Good. But we don't know the height. So a couple things we can do. Let me simplify 3.3 first. 3.3 cubed, or squared, I mean. .3 squared gives me 10.89. Okay, now I'm solving for h. What can I do to both sides? What's one thing I can do? Times 3. Good, get rid of that. Get rid of that fraction. 54.45 times 3, what does that give me? 163. Good, oops. We get 163.35 pi. And then I'm just gonna rewrite this a slightly different way. We have 10.89 pi h. Perla says we can divide by pi. We sure can. But we can divide not just by pi, but also 10.89. What happens to these pi's? What happens to the 2 pi's over here? We got 15, but why? What happens to the pi's? You didn't answer my question. Pi's cancel out. Good. The pi's cancel out, and then 163.35 divided by 10.98 gives me 15. So we end up with answer choice C. 15 centimeters cubed. So that's this one. Any questions? For those of you who got B, if you got answer choice B, I have a feeling that you forgot about the pi. And maybe you divided that by 3. I'm not sure. But does anyone have questions on how we got 15? All right. Now this is it for cones. This is the last question about cones. Any final questions on cones? Okay. We'll do this one tomorrow probably. We got to move on to spheres. Spheres. The volume of a sphere. This is actually the last volume formula that you guys have to memorize. This is the last one. 4/3 pi r cubed. Interesting. Go ahead and write it down, and then we'll watch a video to try to understand it a little bit better. Volume equals 4/3 pi r cubed. All right, is anybody still writing? Okay, so let's go ahead and see if watching a video helps make it make a little more sense. It's very ASMR. All right. So I'm going to play it one more time. And this time, while I play it, go ahead and type into the chat while I'm going on it. Type in, what do you notice? What do you wonder? All right. Okay, so it's obviously not perfect, but basically what's going on here. Yeah, so let me go to the beginning and just explain. So he fills up the cone. So the cone is full. He uses the volume of a cone. He puts it into the pyramid just because I think the reason he does that is because the pyramid is a little bit easier to pour rather than pouring it directly from the cone. But this is the volume of one cone going into the sphere. And like Perla said, he's able to do this 2 times. So basically, how many of these cones fill up one sphere? How many cones go into one sphere? Dos. Okay. Now at the very start, you can kind of see it's a little bit hard to tell because the angle's a little bit off, but these have the same height. They have the same height, and the circle down here has the same radius as the middle of the sphere. Okay, so if you think about the center of the sphere is the largest circle of, right? Because if you tried to measure the radius up here, it would be much smaller. But the largest circle you can possibly get has the same radius as the base of this cone. Does anyone have any questions on what we're seeing in this video? Okay, so let's kind of see what that does mathematically. So we said, all right, 2 cones equal 1 sphere. Jalen, you can call it that if you want, but just remember what it's actually called. Now, the sphere has, like I said, the largest part of the sphere in the very center, that is the longest diameter that you're going to get. If you cut the sphere up here, that's going to be a much smaller circle, right? So we always want to cut a sphere right down the middle. And the diameter, let's call that D, of the sphere is the same as the diameter of these 2 cones. Now, remember what I said, they have the same height as well. They have the same height. So let me draw another line. These will all have the same height. Okay, so same diameter, same height. Now, here's a question for you. Looking at the sphere, what do you notice about the diameter and the height? What do you think? Here's the height, here's the diameter. They both go right through the center. That's exactly right. So let me highlight that. They intersect at the circle, and since they at the center, and since they intersect at the center, what Perla says is completely true. Yeah, they are going to be the same, because a sphere is a ball, right? And a ball, no matter which way you look at it, is exactly the same. So the diameter is going to be exactly the same as the height. Okay, because if you rotate this sphere around 90 degrees, it's still going to be exactly the same. So these two are actually equal to each other. So for that reason, I'm going to just, actually, no, I'm not going to do that yet. So we're going to talk about that in a second. Now, what's the volume of a cone? We already know what's the formula for the volume of a cone. Volume of a cone. Okay, 1/3 pi r squared h. Now we're saying that 2 cones equal 1 sphere, right? So the volume of 2 cones is going to be the volume of 1 sphere. So what I can do is I'm adding 2 of these together. Okay. Now another way to write this would just be 2 times pi r, 2 times 1/3 pi r squared h. We agree? Yes? Okay. And the other part of this is that, well, we know that the height and the diameter are the same, right? So the diameter, or sorry, the radius is half of the diameter. Well, we know that the radius is also going to be the same as half of the height. Do we agree with that? So what does that mean? That means that the height is how many radii? How many radii would make up one height? Remember, the height is equal to the diameter. They're equal. So how many radii make up the diameter? 2. So the height is equal to 2r. Let me draw it out so you can see it a little bit better. Here's 1r. Here's another r. Right? This is radius, this is a radius. Same thing here. This is a radius, and then down here, this is a radius. So the height is equal to 2 radii. So what I'm going to do is I'm going to plug that, instead of writing h, I'm going to write 2r. So instead of writing h, I wrote 2r. Now I know that this is looking a little bit complicated right now, so let me simplify a couple of things. Oh, my bad. Just making this a little bit smaller. Let me not complicate, simplify a couple of things. So I'm going to rearrange this a little bit. I'm going to bring this 2 over here. And then I have pi r squared times r. All I did was I moved this 2 over to the front, okay? Because now what's 2 times 1/3? 2/3. And then what is pi squared, or not pi, r squared times r? R cubed. Remember that we add the exponents. So r squared times r to the power of 1, I get r to the power of 3. And now finally, I'm just going to multiply this 2. 2 times 2 gives me 4. So I get 4/3 pi r cubed. And that's how we get the formula for a circle. For a sphere, I mean. So kind of really interesting to see how it all comes together. And this is something that you can write into your notebooks as well. So we have the volume of one cone plus the volume of another cone. So it would be 2 times the volume of a cone. All we did was we replaced h. Let me highlight that part. H equals 2 times the radius. So I replaced my h with 2r. Then it was just a matter of combining things. So 2 times 1/3 gives me 2/3. R squared times r gives me r cubed. Multiply times 2, and we get our formula for a sphere. So again, kind of similar to when we were just looking at a cone, formulas are great to have memorized, but knowing where they come from is even more important. So we're going to make sure this is memorized. We're also going to think about why that's what the formula is. So take a few more moments to have everything, make sure you write it down, and let's see if there's any questions. All right, any questions, and is anybody still writing? No questions? No one's still writing? Can I move on to the next slide? Yes. Yes. Okay. So let's do a few problems. This is kind of what we're doing for the rest of class. We're gonna find the volume of each sphere. So starting with an easy one, we're just gonna plug everything in. Volume equals 4/3 pi r cubed. And what's the radius? Is that the radius? Yeah, it sure is. So with a sphere, because the center of the sphere, you can, since it's three-dimensional, the radius can come out in any direction at all. Okay. I know it can get a little confusing, but think of it this way. No matter where I go, all of those are equal. Okay, so when you have a sphere, the radius can go out to any point, anywhere at all. So I get 4/3 times 3.7 squared pi. Or not squared. Oh, my bad. Cubed. So when you do this on your calculator, I would say the best thing to do is start with this. So do 3.7 to the power of 3, multiply that times 4, and then divide it by 3. That's the best way to do it on a calculator. So go ahead, take a moment, see what you get. And round your answer to the nearest 10th in terms of pi. "15 seconds, type your answers into the chat. Both of Janelle's and Perla round to the nearest 10th, not the nearest 100th. Good, 67.5 pi inches cubed. So again, when you use your calculator, you're going to plug this number in, 3.7 to the power of 3. Then you multiply that times 4, then you divide that by 3. So 67.5. Number 3, another easy one, but what do you have to do real quick before you actually do it? Yeah. What would the radius be? 5.5. So I'm gonna write this out, but I'm not gonna do it yet because I want to look at number 4 as well. In number 4, I don't know the radius, but I know the circumference. How do you get the radius if you are given the circumference? Good. C equals 2 pi r. So if the circumference is 14 pi, Right, we're just gonna divide by 2 pi on both sides. My pi's cancel out. And I get 7. So go ahead and do these two as well. And then we'll do a couple more and then we'll be done. Make sure you guys are doing number 3 and number 4, by the way. Okay, take about 30 more seconds. All right, let's do number 4 first. Where did my pen just go? Oh, here it is. Okay. For number 4, first thing you got to do is 7 to the power of 3. 7 to the power of 3 should give you 343. But then you got to multiply that times 4 and then divide it by 3. So 343 times 4 is 1,372. And then you divide that by 3 and you get 457.3 pi centimeters cubed. So that's number 4. Number 3, I know a couple of you guys are still working on it, but I do want to move on. So 5.5 to the power of 3, you get 100, oh, hold on. Okay. You get 166.375 times 4 divided by 3. You should get 221.8 pi feet cubed. So those are my 3 answers. Make sure you're getting the same numbers. And if you're still not getting the same number, let me know so we can figure out what's going on. Janelle's, you're not getting the same number. So where do you go wrong? Are you getting this number here? You figured it out? Okay, cool. Anyone else? You got it now, Perla? Yeah, with these types of questions, if you're using a calculator, you always want to do it at least 3 times and just make sure you get the same answer all 3 times. Because sometimes you might make a little mistake, or if you don't, sometimes you have to hit enter after everything you do, just to make sure that you're getting the right answers. You didn't press, yep, that's what happens sometimes. You got to make sure after you get your final answers, you always press enter. Yeah. Okay. These, let's do, let me see. No, we don't have much time. Okay, we don't have a lot of time. There's only 2 minutes left. So I think we can do this one as our bell ringer tomorrow. That's fine. We pretty much got through everything today. My one announcement is that actually I looked at the homework that there is, like I looked at the possible homeworks that I could give you and I didn't like any of them. So for that reason, there isn't going to be a homework this week, but there is a quiz on Friday. So just because there's no homework doesn't mean you shouldn't take a little bit of time every day just to review what we learned in class, practice, do a little practice problems, because there will still be a quiz. Okay, so no homework, yes, quiz. But that's it for today, y'all. Good job. I will see you tomorrow. Okay, bye. I'm gonna leave this up on the screen. If anyone wants to take a picture of it, that's good practice for later. Bye, guys.